4, 3, 2, 1. Booster ignition. And liftoff. The crew of Artemis II now bound for the moon. Humanity's next great voyage begins.
There is a precise moment, measured to the minute, when 4 human beings will cross a boundary that no living person has crossed in 52 years. Not a border on a map, not a political line, a physical threshold. The last wall standing between them and a star that has already killed worlds. 8 hours after launch, the Orion spacecraft carrying the Artemis II crew will exit Earth's magnetosphere. That word gets used a lot. It rarely gets explained. So let's be exact about what it means. Earth's magnetic field, generated by a rotating iron core 5,000 kilometers beneath your feet, projects an invisible electromagnetic shell called the magnetosphere. On the side facing the Sun, it extends roughly 65,000 kilometers into space. That sounds enormous. The Orion capsule will punch through that boundary approximately 8 hours after liftoff. After that, nothing stands between the crew and the full, unfiltered output of the Sun. The Sun continuously fires a stream of charged particles, protons, electrons, alpha particles, at roughly 400 to 800 kilometers per second. Inside Earth's magnetosphere, you never feel it. The field lines curve these particles around the planet like water around a stone. Outside that field, they go straight through you. Under normal solar conditions, this background radiation is manageable. Dangerous over years, but manageable over days. But the Sun does not operate under normal conditions right now. We are currently inside Solar Cycle 25. NASA and NOAA predicted a moderate cycle. The Sun disagreed. Solar Cycle 25 is tracking above its own predicted intensity curve, making it one of the most active cycles in 2 decades. Artemis II's launch window sits directly inside the statistical peak, and that peak has a weapon the crew cannot see coming. April 1972. Apollo 16 returns from the moon. The crew lands safely. The mission is declared a success. 15 months later, in August 1973, the Sun fires. A solar particle event, an eruption of high-energy protons from the solar surface, detonated in August 1972. Scientists have since calculated the radiation dose that a crew caught in deep space during that event would have received. Up to 4 sieverts, whole body, within hours. For reference, 1 sievert is the clinical threshold for acute radiation syndrome. At 2 sieverts, cognitive function begins degrading. At 6 sieverts, without immediate medical intervention, survival probability drops towards 0. Apollo 16 missed that event by 15 months. 15 months. The crew of Artemis II will spend 10 days in that same environment, during Solar Cycle 25's peak. A major solar particle event, classified X-class, can deliver a radiation dose exceeding 1 sievert to an unshielded human body in under 30 minutes. 30 minutes. That is not a statistic designed to comfort. That is a physics constraint with no political solution. Solar energetic particles from the most violent eruptions travel at up to 60% the speed of light. Depending on the event's origin point on the solar surface, the warning time before particle arrival at the crew's location could be as short as 15 minutes. 15 minutes to shelter. In a spacecraft with no emergency escape vehicle, no hospital, no radiation oncologist. 4 humans and a wall of aluminum. And here is what that wall actually does. Orion has a designated radiation storm shelter. NASA engineers designed it carefully. The crew would pack themselves into the forward section of the capsule, surrounding their bodies with equipment, water bags, anything with hydrogen-rich mass to absorb incoming protons. It works. Against solar protons, it provides meaningful attenuation. Against galactic cosmic rays, it provides almost nothing. Galactic cosmic rays are not solar particles. They are atomic nuclei, iron, carbon, silicon, accelerated to near light speed by supernovae thousands of light years away. They do not stop at aluminum walls. They do not stop at water bags. They pass through meters of solid lead. Inside human tissue, they do something worse than pass through. They fragment. Each primary particle creates a cascade of secondary radiation inside the body, a shower of ionizing particles tearing through cells, chromosomes, vascular tissue simultaneously. Apollo astronauts described a phenomenon during their lunar transits. With their eyes closed, in complete darkness, they saw flashes of white light. Not hallucinations, cosmic ray particles physically striking the retinas and optic nerves. High-energy nuclei passing through the skull, through the eye, registering as light because the optic nerve cannot distinguish between a photon and a particle moving at 99% the speed of light. A landmark study published in Scientific Reports in 2016 analyzed the cause of death data for Apollo astronauts. Apollo lunar mission veterans, the ones who went beyond Earth's magnetosphere, died from cardiovascular disease at a rate 4 to 5 times higher than astronauts who stayed in low Earth orbit. Researchers attributed this directly to deep space radiation damaging the endothelial cells lining their arteries. The Apollo crews received mission-averaged radiation doses between 0.16 and 1.14 rads. Artemis II's projected exposure during a solar cycle peak may exceed that range. At maximum lunar distance, roughly 400,000 kilometers from Earth, the crew is 4 days from home at minimum. That assumes optimal trajectory, full propulsion, no additional system failures. If a major solar particle event erupts at that moment, the crew begins receiving a potentially lethal radiation dose. NASA's emergency response teams receive the alert. Engineers run their checklists, administrators convene, and the crew absorbs another hour of exposure, then another. There is no rescue vehicle. No crewed spacecraft on Earth can reach a crew at lunar distance within the biological window. The International Space Station is in low Earth orbit, 400 kilometers up. It cannot help. No nation has a deep space rescue capability. The physics of this are not a policy failure. They are a constraint that orbital mechanics and human biology impose simultaneously. The 4 people chosen for Artemis II know every number in this analysis. They have read the dosimetry reports. They have studied the 1972 event data. They have sat in mission simulations for solar particle emergencies and watched the clock run. They volunteered anyway. That detail does not make the math less brutal. It just means they understand it better than anyone. The Sun does not know Artemis II exists. It has no schedule, no warning light, no obligation to wait. It has fired particle events that would have killed Apollo crews, and it fired them between missions, by statistical accident. Artemis II will place 4 human beings inside that same statistical gap and ask the Sun to hold. For 10 days. This is not a failure of engineering. Orion is the most radiation-hardened crewed spacecraft NASA has ever built. But hardened means resistant, not immune. And resistant has a number. That number is smaller than what a single X-class solar particle event can deliver in under 30 minutes. The universe does not grade on effort. It does not reward ambition. It applies the same physics to the courageous and the cowardly without distinction. 4 human beings are about to cross the last wall Earth offers and place their survival in the hands of an 11-year stellar cycle that peaked ahead of schedule. Whether they come home depends in part on a star 150 million kilometers away, doing nothing unusual for 10 days. If that reality changes how you see the sky, subscribe and keep watching the dark truth of the universe via Aius.